Okay, so here's another interesting observation regarding some rules surrounding the idea of factors of a polynomial expression. That is, if we know we've got a polynomial function and we have a linear factor x minus c as one of the factors of that polynomial, we can actually tell something about the behavior of the graph by looking at the number of times that that polynomial factor repeats, that is raised to some power. Well, here's the rule. It says that if c is a real number and the polynomial function p has x minus c as a factor exactly k times, then the graph of p will, first of all, intersect but not cross the x-axis at that point c0, provided k is an even positive integer. All right, that k is going to be some power. And it will cross the x-axis at that point c0, provided k is an odd positive integer. All right. Well, what does that mean? Let's determine this graph's behavior at these points right here. We've got this polynomial. It's already in factored form, right? P of x is equal to x minus 4 to the third power times x plus 3 to the second power. If we were to write that out, what does that actually mean? Well, we would actually consider P of x to be the kind of function that has repeated factors of x minus 4, right? X minus 4 times x minus 4 times x minus 4, and we would have x plus 3 repeated twice, x plus 3 times x plus 3. So now that we know this is the factored form, and we notice that these guys repeat 3 times, while these guys repeat twice, we could find out what happens where the graph intersects but does not cross the x-axis or does cross the x-axis. Well, our rule up here says that the graph will intersect but not cross the x-axis at c0, provided k is an even positive integer. So that means if we were to go to the point negative 3, 0, we could tell you something about the behavior of this function right now. At the point negative 3, 0, this graph will intersect but does not cross the axis. So it would probably come along somewhere like this along the x-axis and bounce off. It intersects but does not cross the x-axis at x equals negative 3. Intersects but does not cross at x equals negative 3. And we can tell that because if we look at our exponent for p of x, k is equal to 2 according to this rule. It's an even factor, even power factor. Now, on the other hand, we have the graph intersecting the x-axis at x equals 3. So, at the point 4, 0, this graph will cross the x-axis but might not actually intersect it. So what's going to happen right here is that we could have this graph be the kind of graph that crosses through the x-axis, right, and intersects the x-axis at the same time. So what would happen right here, in fact, I think I could tell you right now if I were looking at this graph, what should happen is probably something more like this. The graph would bounce off down here and it would cross through. And I could tell you right now there's an interesting thing that's got to happen right here. This graph has got to go way down and then come back up and off to the right, head up, and off to the left, head down. Why do I know that? Look at my leading coefficients test. This polynomial would be third times second fifth degree and would have a positive leading coefficient. So my far left hand and right hand behavior actually gives me a little bit more information about this graph. But in any case, to answer the question, the graph crosses the x-axis at x equals 4, and we know this because, at the point 4, 0, because k is an even number. K is an odd number in this case, k representing the power for that particular factor. Okay, one more to go here.